Hello everyone. In this video we'll be discussing the basic fundamentals of electricity. This comes under the subject Basics of Electrical and Electronic Engineering from Electronics and Instrumentation Engineering subject. So before going to the actual subject, we'll discuss what is all about electricity and how current what are the things that make current flow in the circuit. For that we need to know the basic point of electricity. So for that I'll be before knowing what is meant by current, voltage and resistance, we'll first discuss what is about um, electron. So before that we'll just know what is meant by atom. Atom is the smallest particle that includes you, me and everything. Every material that is present on the earth is made up of the smallest particle that is known as atom. Atom uh, has a central part. The central part of the atom is called as nucleus. In that nucleus we have two different particles called as neutrons and protons. Neutrons have neutral charge and protons has positive charge. In the nucleus we have the same amount of neutrons and protons, and uh, in the uh, outside the nucleus we can find some elliptical shells or orbital shells on which electrons will be revolving around the nucleus. So we can see in this diagram that central part is made up of nucleus. In that nucleus we find some protons and neutrons which are of equal number. Outside the nucleus we find some electrons revolving, and the deposition of electrons in each orbit or each shell is based upon a formula called as 2n square. So the number of atom accommodation in each cell is based upon this formula. the, for example, if I take the first shell, it has it can accommodate uh, two electrons, based on the formula 2n square. 2 into, here n I can take it as 1. 2 into 1 square is 2. So the first orbit can accommodate two electrons. The second orbit, 2 into 2 square, that is 8. It can accommodate 8 electrons. Likewise, for each orbit there is a specific number of electrons to be accommodated, and the outermost orbit or else outermost shell which contains some electrons, those electrons are called as free electrons. For example, in this copper, for the copper, the number of protons is 29, neutrons 36, and number of electrons is 20. So the proton and electron number will be always equal. So from the proton number we can um, uh, we can uh, suggest the number of electrons. So for a copper atom, the first orbit can accommodate 2 electrons, second one can accommodate 8, third 18, which totals an amount of 28, and the remaining 1 electron will be in the fourth orbit, and this electron which is in the fourth orbit we call it as free electron. So this free electron is now responsible for the flow of current. So this orbit, as it is an unstable atom, can move from its orbit to the other places, as the Bohr's atomic model suggests that when a atom is given, or when an electron is excited by an energy, it jumps from the lower energy level to the higher energy level. Likewise, based upon this theory, the outermost orbit, which has one free electron, will move from its original orbit and jumps to the other state, or it becomes free, such that its movement will generate current. now we can see this, the electron when it is excited is coming out and moving freely. This free electron is responsible for the flow of current. For any solid material or any substance, we have millions and millions of atoms, such that uh, one free electron can make a huge amount of current. So these current, likewise, based upon this theory, any solid material, we can simply say that it can be an insulator or conductor. The more, for any conductor, there will be more number of free electrons, that is, atoms will be unstable. Whereas for insulators, the atoms are perfectly packed and those are stable. That is, atoms will be completely fully packed. Atoms will have, for any insulator, like for example rubber, glass, or silicon rubber, the atomic structure is such that the outermost orbit does not have any free electrons. Whereas for the conductors, like metals, all metals come under the category of conductor. For example, for a copper, copper, silver, aluminum, etc., they come under the category of conductors. For conductors, the atomic structure or the atoms are not stable, so that the availability of free electrons is there for conductor. So when we excite and or we supply energy for the conductors, uh, free electrons will be readily available, and these free electrons are responsible for generation of current in the circuits. So the generation or conduction of current is purely based upon the atomic structure and the number of availability of electrons. The more the availability of electron, the more the conductivity. The less the availability of free electrons, less conductivity. Or if there is no availability of electrons, simply we can say that that material, or simply we can conclude that the material come under can be called it. We can call it as an insulator. So. Uh, For the conduction of current or flowing of current, we need to keep it in when no current. For example, if we take a copper wire, when no current is applied, the free electrons within the copper atom will move randomly between other atoms. When a current is applied, the free electrons within the copper atom will move in the same direction between other atoms. So here we can see that mm, when there is no application of any external voltage, the free atoms that are available in the conductor will be moving randomly uh, within inside of it. Whereas when we apply a proper potential, the proper potential, or if we apply an external power supply, or when current is applied, these free electrons will move in the same direction, and that is, all the atoms will all the free electrons will follow a particular direction. So that particular direction can be of two types, that is conventional current, other one is electron current. Electron current, we say that electrons flow from positive terminal of the battery to the negative terminal of the battery. Whereas conventional current, we say that the current flowing in any circuit will be from negative terminal of the battery to the positive terminal of the battery. for, for current to flow, there should be a proper circuit. Circuit is nothing but the route of electrons which can flow along. That is, circuit is nothing but a closed loop in which electrons will be flowing in a particular path, causing some voltage drop, some resistance, development of power, etc. Here in this on the screen you can see two circuit. First one is closed circuit on the left side, the other one is a open circuit on the right side. If you see, there is a load, connecting wires, and a power supply. Here LED light is a load, whereas the green and black ones are the connecting wires, and the battery is external power source. So for any circuit, we basically or we generally have these 3 points, like a voltage, external power supply, connecting wires, and a load. So for this load to be operated, we have to have the connecting wires properly connected to the external power source. For, and the major concern about the circuit is that the circuit should be always closed circuit. So for in any open circuit, like in the right circuit, we see it is an open circuit. For in any open circuit, current will not be flowing. So for the flow of current, the circuit should be always closed one. In any closed circuit, current will be flowing. For example, in the for the LED light to be glown, the closed it should be a closed circuit. With this, we got to know what is meant by who is responsible for current, and for the proper flow of current, what are the things that we have to keep in mind. That is nothing but the circuit, where we have seen the circuit connection. Now we will move on with the subject, that is voltage, current, and resistance. So for today's session, we'll discuss the basic definitions, units, and how we can represent voltage, current, and resistance in any circuit. The first one is voltage. Voltage is nothing but it is a measure of electrical potential energy per unit charge. It is generally represented by symbol V. Metric unit is voltage, and it is abbreviated with the letter V. 1 volt is equal to 1 joule of electric potential energy per coulomb of charge. So 1 volt is equal to 1 joule divided by 1 coulomb. For example, if the voltage is equal to 12 volts, we can say that V is equal to 12 volts. The next definition is current. Flow of electrons. Current is nothing but free flow of electrons. In general, we can say that in general sense, current is defined as free flow of electron, but technically speaking, current is nothing but flow of charge carriers. These charge carriers can be either electrons or holes, but the majority of charge carriers that are available in any conductor are electrons. So in general sense, we say that current is nothing but free flow of electrons. So the rate of flow of charge past a given point in any circuit. In general, it is abbreviated. It is the units. The current is represented by letter Its units are amperes, so or simply we can say it as amps, and this unit is abbreviated by letter A. So 1 ampere is equal to 1 coulomb of charge flowing past a point every second. That is, in other words, the units of current can also be defined as number of charge carriers that are moving for any cross sectional area of a conductor in a given time or in a second. That is, number of charge carriers divided by time. So the unit of current can also be given as J coulombs per second. That is, I is equal to Q by S. Coming to the resistance is the other point which plays a major role in any electrical circuit. Resistance is nothing but it is the opposition or hindrance to the flow of current or flow of charge. Resistance, depending upon the resistance, we can say that how much of current will be flowing in the circuit. Always remember that there is an inverse relationship or else relationship between current and voltage. More the resistance, less the current flowing in the circuit. Less the resistance, more the current that will be flowing in the circuit. And based upon constant values and based on Ohm's law, we can say that the ratio of voltage applied to the electrical current that flows through the resistor R is equal to V by I. So in simple terms, resistance is equal to voltage that is applied in the electrical circuit divided by the current flowing in that particular resistor. Resistor is represented by symbol R and its units is ohm. For example, 50 ohms can be represented as this symbol ohm. This is a symbol for resistance. In short or in brief, we can say that voltage is abbreviated by letter capital V and its unit is voltage, or the unit of voltage is volt, and this is abbreviated as capital V. For example, V is equal to 9 volts. It is indicating that voltage is equal to 9 volts. The other one is current. It is abbreviated or indicated by capital letter I, and the unit for current is amperes. And ampere is abbreviated by letter A. For example, I is equal to 1.5 amperes means the amount of current I is equal to 1.5 amperes indicated by A. Resistance is nothing but R. It is indicated or abbreviated by letter R, and the units are ohms and indicated by symbol inverted U. And if R is equal to 7 ohms, it shows that the resistance offered by that particular resistor is equal to 7 ohms. So with this we got to know the basic fundamentals of electricity, that is how current will be flowing. For that, what is the basic carrier, or what is the structure of an atom. In that atom, who is responsible for the flow of current, and what is meant by free electrons, and how the atomic structure looks